All right, today we're going to talk about vector operations. So the first thing we need to understand is the component form of a vector. So if I have a vector AC, what we're going to have is we're going to have an initial point, which is A, it's x1, y1. We have a terminal point C, it's x2, y2. So my component form is just the differences. It's x2 minus x1, y2 minus y1. It almost looks like a coordinate, but we don't use parentheses, okay? So here's our example. So I need to find the component form of CF. So C is -4, -3, F is 1, 5. So the component form is 1 minus -4, comma 5 minus -3. So I have 1 plus 4, which is 5, 5 plus 3, which is 8. So this is the component form. Now, when we're talking about the length of a vector, that's basically the magnitude. So we're going to use Pythagorean's theorem here. So the magnitude of the length is equal to the x component squared plus the y component squared square rooted. And that's kind of what we have in our diagram. In your book, they have it as V1 and V2 because we're kind of basing it off this idea. So if I have a vector and its component form is 5, 8, what we're going to do is we're going to square 5. So I have 5 squared plus 8 squared, and we're going to take the square root of that. So 5 squared is 25, 8 squared is 64, so I have 25 plus 64, so it's the square root of 8. So that's the length of a vector. So if vectors are equivalent, so if I have the same vector, there's two things that have to be the same. Their components have to be the same. Okay, they don't have to be in the same location. They can be all over the graph, but if their component form has to be the same, then the vectors are the same. So here I have U is the component form is U1, U2. I have vector V is V1, V2. If these are the same numbers in here, then these vectors are the same. If the vectors are the same, then these components are going to be the same. So we're going to talk about scalar multiplication. Remember, scalar multiplication is just multiplying by a real number. So I have a real number k, and I have a vector, v, which is v1, v2. So if I'm going to take this scalar here, k times v, vector v, it's going to equal k times the component form, and then you're just going to multiply that k into each piece. Now, one of the things I probably should stop you, when you're looking at these vectors, these are going to be bolded in your text. So understand that U and V are bolded. If it's not bolded, it's just a scalar. It's just really hard to draw it bold on the whiteboard. So here we have a scalar of 5 and a vector of 2, 7. So if I'm going to multiply this through, scalar multiplication says 5 times the component. So 5 times 2 comma 7. So that gives me a scalar multiplication, a new vector of 10, 35. Okay, so that's scalar multiplication. Now, I have vector addition and subtraction. If I am going to add or subtract vectors, I'm going to do that by adding or subtracting their individual components. So if I have vector U equals U1, U2, and vector V equals V1, V2, if I add or subtract these, I'm going to add or subtract the components. So if I have U plus V, I have U1 plus V1, comma U2 plus V2. If I'm subtracting, I subtract the components. U minus V is U1 minus V1, and U2 minus V2. So remember, you can add or subtract those. So here I have vector U is 1, 5. I have vector V is 2, -4. So if I add these, U plus V, I'm going to add the individual pieces. So I'm going to add the quote-unquote x component to the y component. So 1 plus 2. So 1 plus 2. 5 plus a -4. So that gives me a vector of 3, 1. So u plus v is going to give me 3, 1. Now a unit vector, so a unit just means one piece of it, is what we're going to do is we're going to take and find the length or the magnitude of that vector and divide the components by that piece. So this is our unit vector. It's vector v over the length. Okay? So if I have a vector here, which is -3, 5, and the first thing I want to do is I want to find my length or magnitude. So I'm going to come here and I'm going to square each piece. I'm going to square -3, I'm going to square 5. So that gives me 9 and 25, which gives me a square root of 34. And then I'm going to take and put this vector over that and multiply it in. So I have negative 3 over the square root of 34, 5 over the square root of 34. This is my unit vector here. And so that kind of gives us an idea of how that's going to work. Yes, we could rationalize the denominator. We're not going to do that right now, but you could do that. Properties of addition and subtraction. So all the properties that you had with numbers basically hold true in a vector. So if I have vector u plus vector v, that's the same as vector v plus vector u. If I have vector u plus the quantity of vector v plus vector w, I can rearrange that and have it be the quantity of u plus v plus w. So if I have vector u plus the 0 vector, I get vector v. If I have 1 times vector v, I get vector v. If I have 0 times vector v, so I'm taking a scalar multiple of 0, I get the 0 vector. Doesn't move. I have inverses. Vector u plus the negative of vector u gives me the 0 vector. So here if I have scalar b times the quantity scalar c times vector v, I can actually multiply those scalars together first and then multiply it by the vector. If I have two scalars here being added with and then multiplying by a vector, so b plus z times vector v, I can actually kind of multiply that in, bv plus cv. If I have the scalar b plus vector u plus vector v, I can go bu plus bv. So all these properties hold true. Okay? So what we're going to look at now is we're going to look at what we call the dot product. So I'm going to erase this real quick. So here we have dot product. And dot product is a way that we can get a scalar, a number that represents these two vectors. So if I have vector u equals u1, or put it in vector form, u2, and I have vector v equals v1, v2, if I want the dot, if I want u dot v, what's going to happen is I'm going to actually multiply the components together and add them. So this becomes u1 times v1 plus u2 times v2. Okay? So if I have two vectors here, let's go over an example of this. So let's say I have 2, negative 5, and I have vector v equals 0, 4. Okay? So if I want u dot v, what's going to happen is I'm going to go 2 times 0 plus negative 5 times 4, 2 times 0 is 0, plus negative 20, right, which gives me negative 20. There's my dot product of those. Okay. So the last thing we're going to talk about is finding the angle between these two vectors. So what we can do here is cosine theta equals u dot v over the magnitude of u times the magnitude of v. Okay, this is very similar to kind of what we've been doing last section. So if I have a vector u here of 3, 7, and a vector v equals negative 4, 2, I can now find the angle between those. So the first thing I'm going to do is I'm going to find the magnitude of u. Okay, so that becomes 3 squared plus 7 squared, which is 9 plus 49, which is the square root of 58. I'm just going to leave it as the square root of 58. I don't have to find the decimal equivalent. I'm going to find the magnitude of v here. So I have negative 4 squared plus 2 squared. So I have 16 plus 4, which is the square root of 20. And I'm just not going to simplify them right now because eventually this is going to work out to be a decimal anyways. So now I'm going to find u dot v. Well, u dot v is 3 times negative 4 plus 7 times 2, which gives me negative 12 plus 14, which is 2. So going back up to our formula here, we're going to find our angle between these two vectors. So cosine theta equals my dot product. I've already found my dot product, so I'm going to put that up here. 2. I've already found my magnitude of u and my magnitude of v. Square root of 58, square root of 20. Okay. Now what I'm going to do is I'm going to take my calculator and I'm going to actually find that information here. Just understand that when you're doing this, make sure that you use parentheses where you need to be. If you're using a calculator, you're going to need to put parentheses around that whole thing. So 2 divided by the square root of 58 times the square root of 20. That gives me a decimal point 0.05872. And now what we're going to do is to find theta. We're going to go cosine inverse of 0.05872. And we get an angle of 86.6 degrees. So we want to make sure that you can find the magnitude for each of them, find the dot product, and then you're just going to put it in this formula. Okay. I know that's a lot of information about vectors, vector operations. Most of it's pretty straightforward. You can go back and look at those as examples.